Hi, here's a short video on how to identify the number of solutions you will have after solving a system of equations. So we are so used to the one solution method. You always get a solution, everything always works out perfectly. You never have to worry about special cases. But in honors geometry, we are going to look at special cases where we have no solution or infinitely many solutions. So what does that look like graphically and algebraically? Well, graphically, that looks like no solutions are parallel lines. They never cross, they're never equal. And infinitely many solutions happen when I have one line right on top of each other. They touch it an infinite number of points, so they have infinitely many solutions. And how do I know algebraically what that's going to look like? Well, I've got a few problems selected. If I have one solution, I get a nice ordered pair. If I have no solution, I'm going to get a false statement. And in infinitely many solutions, I would get a true statement. And in both of those special cases, all of my variables would go away. They would all reduce, and I would end up with a true statement. And if you simplify all the way down, it would be 0 equals 0. So for example, let's look at this one right here. 2x plus 2y equals 10, and y equals 5 minus x. Now this is an elimination problem, and I know, this is a substitution problem. This is a substitution problem, definitely substitution, because I've got an isolated variable. So excuse that little mistake there in speaking. It is a substitution problem because I will substitute this value for y. So 2x plus 2, and what is y? 5 minus x equals 10. You end up with 2x plus 10 minus 2x equals 10. Or 0x plus 10 equals 10, or 0 equals 0. Or just 10 equals 10. So here I have a true statement. 0 does equal 0. And all of my variables were eliminated. So this means this must have an infinite number of solutions. Now, on the other hand, let's say I had a problem like this. This one is elimination because none of my variables are isolated. So what I'm going to have to do is multiply both equations by some factor, in this case 5 and 2, to get 20x plus 30y equals 15, and negative 20x minus 30y equals negative 8. And when you simplify, you get 0 equals 7. And I know that that right there is a false statement. 0 never equals 7. So this must be no solution. That's how I would identify algebraically how many solutions I have when solving a system of equations.